Hello, I'm Mr. Bob, and welcome to my Algebra 1 review series. This video covers Chapter 10, Section 8, titled Using the Discriminant. By the end of this video, you will have reviewed recent lessons describing the methods using the discriminant to know the number of real solutions there are in a quadratic equation. You will use the discriminant to better understand your quadratic equation, and finally, you will have reviewed the solving of a real-world problem requiring the use of this discriminant for its solution. If you would like me to cover any of these topics in greater detail, please leave your request in the comment section below. Please subscribe to this channel if you find the video to be helpful. Thank you. Okay, let's start by going over a definition of the discriminant. Quadratic equations can have two, one, or no solutions. You can determine how many solutions a quadratic equation has before you solve it by using the discriminant. The discriminant is the expression under the radical in the quadratic formula. Okay, objective 1, the number of real solutions of a quadratic equation. So this is basically the definition we just read, but we'll read it again. Quadratic equations can have two, one, or no solutions. You can determine how many solutions a quadratic equation has before you solve it by using the discriminant. The discriminant is the expression under the radical in the quadratic formula, shown here in red below. See it? b squared minus 4ac, right here. This is, oh, there's my pen right there, That's the discriminant. So it pays to memorize that, b squared minus 4ac. So then we look at the little chart here. It says, consider the graphs of the functions below and the discriminant of each related to the equations. Okay, so the first one, x squared minus 6x plus 3. If you run that through the discriminant, you're going to see the b squared, which is negative 6. Down here at the bottom it says, where'd my pen again go, right? Negative 6 squared minus 4 times 1 times 3. 1 is the a term, where there's a 1 with the x squared, and the 3 is the c term. Right here, the c term. So we fill these in. We get negative 6 squared is 36, minus 4 times 3 is minus 12 or negative 12. 24 is the answer, and it's positive, so that means there are two solutions. And what are those solutions? If you look at our graph, you can see there's two, because what's happening? Our quadratic equation, the graph of our quadratic is crossing the x-axis in two spots, and both of those are the solutions. Okay, let's go to the middle one, x squared minus 6x plus 9. So if you put it, fill in the discriminant, you're going to get, again, minus 6 squared, which is 36, and you're going to get minus 4 times 9 is 36. 36 minus 36 is 0. It says you're only going to have one solution. Well, looking at the graph, you see that this quadratic only touches the x-axis in one spot. One solution. It touches it right there at 3. That's a solution. Okay, so now let's look at the final one. X squared minus 6x plus 12. Again, minus 6 squared is 36, and it's minus 4 times 12 is 48. 36 minus 48 is negative 12. And that says there are no solutions. And look at, here's our x-axis way down here, and in no time does this act as the quadratic, the graph of the quadratic, touch the x-axis. It's floating above it, so to speak. There are no solutions. Okay? So the relationship you see between the graphs and discriminants is true for all cases. If the discriminant is positive, there are two solutions. That's our first graph. If the discriminant is 0, there is one solution. That's our center graph. And if the discriminant is negative, there are no solutions. And there's our third graph. Okay, so again, for slide B, if you will, on this, we just see some pictures here. The graph is showing the three cases together. So you can see if the discriminant is positive, you're going to have right here, you're going to have two solutions right here, one of them right here, one of them right here. And you can see that the vertex is below the x-axis. If the discriminant is 0, the vertex is right here right at the line, touching it only in one spot. And if the discriminant is negative, you see that it's like the graph of the quadratic is floating above the x-axis. It doesn't touch it. And to read the property of the discriminant, read this again. For the quadratic equation, ax squared plus bx plus c equals 0, where a is not equal to 0, and we know why it can't be equal to 0, because if it was, it would not be a quadratic. It would be a line. It would be bx plus c. You can use the value of the discriminant to determine the number of solutions. So if b squared minus 4ac is greater than 0, there are 2 solutions. Right here, 2 solutions. If b squared minus 4ac is equal to 0, there is 1 solution. And if b squared minus 4ac is less than 0, there are no solutions. Okay. Okay, for example 1, using the discriminant, find the number of solutions of the quadratic 3x squared minus 5x equals 1. Well, so before we can actually find out, we have to write this quadratic in standard form. And that means we have to bring the 1 to the left-hand side of the equation to make it part of the quadratic. Okay, so then you see it's right here. We moved the 1 from the right side over here to the left side. So 3x squared minus 5x minus 1 is equal to 0. So now you have our discriminant, b squared minus 4ac. So b is negative 5. Okay, so this is negative 5 squared. And then you've got the minus 4ac, which is minus 4 times 3 times negative 1. Negative 4 times negative 1 is 4. 4 times 3 is 12. So we have negative 5 squared, which is 25, plus 12 is 37. That means that there are 2 solutions, because 37 is greater than 0. Okay, example 1, check your understanding. Find the number of solutions for each equation. You go ahead and stop the video and give them a try on your own. And when you come back, we'll look at them together. Okay, I'm assuming you've stopped it and you've returned. So question or problem A has a quadratic, but it's not in standard form. So we're going to have to put it in standard form. And to do that, we're going to say x squared. Now we have to move the 2x to make it a negative 2x on the left-hand side. And we're going to take the negative 3 and make it a plus 3x, or plus 3 rather, excuse me, on the left-hand side. And that equals 0. Now we're going to have the quadratic, the discriminant is b minus 4ac. So over here we're going to have what is x? X is, b here is a 2. So it's going to be 2 squared. Oh, excuse me, minus 2. Excuse me, minus 2. Minus 2 squared. And then it's going to be minus a 4 times a, which is a 1, times c, which is negative 3, or positive 3, times 3. And this will be 4 minus 12. And 4 minus 12 is negative 8. And negative 8 is definitely less than 0, which means there are no solutions. Okay, let's try this problem B. Problem B says, again, it's a quadratic, but it's not in standard form, so we're going to have to move the 7 to the left-hand side. So we're going to have 3x squared minus 4x minus 7 equals 0. And using this discriminant over here, we're going to have b squared, which is minus 4 squared minus 4 times a, which is 3 times 3 times c, negative 7. Okay, And what does that equal to? It's going to equal 16. Minus times a minus is a plus. Plus 12 times 7 is 84. And is equal to what? 84 and 16? 94 and 100. 100 is greater than 0. So we have two solutions. And now let's do C. Again, not in standard form. So we're going to have to make it standard form. So we're going to say 5x squared. We have to move this 2x to the left-hand side. So it's a negative 2x plus 8. Plus 8 is equal to 0. Using the discriminant up here, we have minus 2 squared. Minus 2 squared minus 4. A is a 5 times 8. 20 times 8. Well, we're going to start off with 16. That's not 16, excuse me. Jumping the game here. There's a 4. Sorry. 2 minus 2 squared is a 4. And that is equal to minus 20 times 8 is 160. Okay, so it's really a minus is equal to minus 156. And is negative 156 greater than 0 or less than 0? It's less than 0. So that means there are no solutions. Okay, so now for example 2, we have a real world problem to solve. And this is a fun problem. And in the future, if you stick with mathematics, you'll see a number of these types of problems, and they're fun to look at and think about. So it's a physics problem. A construction worker on the ground tosses an apple to a fellow worker who is 20 feet above the ground. The starting height of the apple is 5 feet. Its initial velocity is 30 feet per second. Will the apple reach the second floor worker? Well, if we look at this, we're going to try to fill in. And what do we need to fill this in? We need to have our vertical motion formula, right? In fact, it says right here on the notes here, it says use the vertical motion formula. And what is the vertical motion formula? It's minus h, the height, is equal to negative 16 t squared, that's time squared, plus the velocity times time squared, plus a constant. And that constant is the initial location in h, in feet in this case, above the ground, so to speak. If this was 0, it means it'd be laying right on the ground. But instead, this is 5 feet above the ground, so we're going to have a 5 right here. So now we fill in. H is a 20. That's how high we're looking for it to get to, is 20 feet above the ground to the worker up on top. Minus 16 t squared. You don't do much with that. But plus v t. V is 30 feet per second. It's right here, 30 feet per second. That's our v term. Plus 5. And 5 is the starting location of the apple when the apple's released from the worker on the ground's hand. So now that we have that, we're going to put it into standard form. So it's 0 is equal to minus 16t squared plus 30t. And we had a plus 5, and now we have a minus 20 because we had to subtract 20 from both sides. So now we have a minus 15 down here, right here. Negative 15, negative 15. Okay, now we've got this negative 15 in the equation. So b squared minus 4ac is 30 squared minus 4 times negative 16 times negative 15. So our answer is, this is negative, this second term. 16 times 15 times 4 is 960, and 30 squared is 900. And if you subtract 960 from 900, you get negative 60. So does the apple reach the worker 20 feet in the air? And the answer is no. It will not reach. Okay? So that's the answer to that question. Oh, and I guess before I hang up, I'll say that this is using the discriminant, right? So since there are no solutions, you asked a question about will the apple reach the worker? And since there are no solutions, I mean, no, it cannot reach the worker because there's no solution that says it does reach the worker. Sorry, I thought I'd just add that in. Okay, example 2, check your understanding. You should stop the video, please, and try this on your own. And when you get back, I'll wait for you, and then when you get back, we'll do it together. But the question says, suppose the same construction worker tosses an apple with an initial upward velocity of 32 feet per second. The other one was 30 feet per second. Will the apple reach the second worker? Well, I'll wait for you. Go ahead and find out. And then when you come back, we'll solve it. Okay, I'm assuming you've done that. We are back. So the first thing we're going to do is we're going to rewrite this equation. So we're going to start off by saying we're going to move the 20 to in this case, the right-hand side, because we need it in the quadratic in standard form. And to do that, I'm going to now write it. So it's 0 is equal to negative 16 t squared plus 32 t, and 15 minus 20 is minus 15. Okay? So now it's in standard form. Let's use our discriminant, b squared minus 4ac. B is 32, so it's going to be 32 squared minus 4 times a, which is negative 16, times minus 16 times negative 15. Negative 15. Okay, so now we have to crunch these numbers, if you will. So this ends up 1024. 32 squared is 1024. And it ends up minus, because all these minuses add to a negative. 3 negatives make a negative. Minus, and if you multiply all these up, you're going to get 960. Okay, so 24 minus 960 is 64, right? 64. And this is a positive number. So the answer is positive 64. So will the apple reach? The answer is yes. Okay, good work.